All right, we do need to talk here next about equations of lines a little bit more. We've so far, I think, well, they might have snuck another form of the equation of the line in on you on a previous section, but we are going to talk about more specifics here. So far, we've talked about the standard form of a line, and that is one like 2x plus 3y equals 12. So-called standard form because it's got the x and the y term on one side, doesn't have any fractions and all that. Some other forms. A real important one, or I think pretty important one, let's talk about a little bit. The slope-intercept form of a line. This one is, well, it's a lot of times the way you see a line in a lot of different scenarios. So we do need to talk about it. Now, what it looks like, you may have heard it mentioned before, but the general form of it we usually call the y equals mx plus b form. That's the slope-intercept form of a line. So called because m, well, m is the letter designation of slope. So there it is appearing in this form of the line. And b is the y-intercept, or the y-coordinate of the y-intercept. So hence the name slope-intercept. Okay. Yeah, some really good information is provided when you have this form of your line. Let's just take a, for instance here, y equals 2x plus 6. This being in the slope-intercept form of the line, which, by the way, how is this distinguishable from the standard form? The y is on a side by itself, right? Slope-intercept form is different than standard form because you have the y on a side by itself, or it's solved for y. Okay, but if you have that, what you can read right off of the equation there is you can read the slope and the y-intercept right off of that. You can't do that for that one, but you can do that for this one. What's my slope here? Yeah, this is saying my slope is going to be 2. And then the 6 is telling me the y-intercept. The y-intercept is 6, or it crosses the y-axis at 6. Or more specifically, we would say, you know, we were really sticklers about this last time, the y-intercept is 0, 6. Yeah. Right off of that equation, from those two numbers, you can tell those things about this equation. You can't do that, like I said, you can't do that in standard form. You have to do a little work to get the slope out of that line. You have to do a little work to get the y-intercept. But on this one, you just read it right off the equation. It's y equals mx plus b. Now, let me just verify that for you. We won't do this probably again, but let's verify those things. The easy one to verify, of course, is the y-intercept is 6, because how do we find, from last time, how do we find the y-intercept if we do it from scratch, so to speak? Well, the y-intercept we set x to 0. Okay, so we set x to 0 and solve for the y. All right, well, that's going to be real easy here, because if x is 0, that's 0. 2 times 0? Okay, so yeah, that's almost a give me there that that's going to be the y-intercept, because if this is 0, then that's your y-intercept. Okay. Now, that is 0, 6. Now, to verify this is a slope, like I said, let me just do this one time with you. To verify that that is the actual slope, let's use what we also know about lines, and that is the slope formula. The slope formula is m equals the y2 minus y1 over x2 minus x1. The formula we used a little bit last time. We'll use it a little more this time as well. But for now, yeah. Now, to use that, what do you need? You do need 2 points. I've got 1 point. So let me get a second point just over here, and let's go ahead and get the x-intercept. Let's let y be 0. Y is 0, so that's 2x plus 6 equals 0. Subtract the 6, divide by 2. And that would give me negative 3, or negative 3, 0 is my second point. All right, so using these 2 points, point 1 and point 2 here, let's calculate the slope and see if it does equal 2. All right, so we take my second y, which is 0, minus the first y, which is 6, second x, negative 3, minus the first x, which is 0, negative 6 divided by negative 3, which is positive 2. There you go. So yeah, without having to do any of that work, now we know this is the slope of the line. This is the y. This is the slope. This is the y-intercept. Okay? Always will be given there. All right. Now, one of the exercises that they have in the book on this is one that goes like this. Say we had 3 graphs here. A graph is this one. It kind of starts in quadrant 3, cuts across quadrant 2, and goes to quadrant 1 like that. All right, B, well, B is similar, but it starts in 3 and cuts through 4, then to quadrant 1. And then C does this. Slanted the other way, starts in quadrant 2 and then goes down, and then D, well, it cuts across quadrant 3 or something, however you want to say it. All right. So those are the 4 choices that we have. Which one of those would most look like, or most looks like, number 1, y equals 2x minus 3. Well, this is, again, this is just an exercise on the information that this equation provides me. This is in y equals mx plus b. This is the m, and this is the b, which is telling me that I have positive slope, positive 2 slope, and I have negative 3, negative y-intercept. See that? Positive slope, negative y-intercept. Because that's really the information all I need, because it doesn't really have markings here on the graphs. I guess we could put them in, but no need to. Just knowing these 2 things. All right, since it has a positive slope, that narrows it down to 2 of them, doesn't it? Which 2 does it narrow it down to? A and B. A and B have positive slope, C and D have negative slope. They're downhill. So it's got to be A and B. Now, which of them has the negative y-intercept? B. Okay, that's it. Negative y-intercept, positive slope, uphill. Okay, that's all that's really asking. All right, so which one would this be? Y equals negative 4x plus 1? A, B, C, or D? Which one? D? Well, we've got a negative slope, right? Change your mind? Negative slope, but positive y-intercept, isn't it? So the negative slopes are C and D. This one has a positive y-intercept. This one has a negative, though, y-intercept, doesn't it? Talking about the y-intercept. Now the other, the x-intercept is not provided on this equation. We have to find it. So yeah, we're looking at y-intercepts, where it crosses the y-axis. And so, which one? How about C? Yeah, that one would be C. Is that okay? All right on that? Okay. All right. Now, if may ask for us to take an equation and rearrange it from one form to the other. If I, and this is the way I'm going to approach it. Let's say I've got y equals let's do negative 3x plus 5. First of all here, y equals negative 3x plus 5. That's in slope-intercept, right? If I want the standard form, let's talk about that, what that would mean here. If I want the standard form of that, what would that mean? What do you think that would mean? Well, in standard form, we need the variables on the same side, don't we? We need the x and the y term over on the same side. So this would be very easy here to do that. And that would just mean move this term over there, wouldn't it? Add it to both sides, add 3x to both sides. Now it's not going to combine with that, so and usually they like the x term first. So that left side would then just be positive 3x plus y. Both terms are positive. And then on the right side we have just 5. Okay? So there's your standard form. Now, a couple of quick little things. If it was y equals 2x minus 7, same thing, isn't it? To change it to standard form, again, just being able to change from one form to the other is going to be helpful. In this case, we're going from y-intercept, slope-intercept form to standard form. Just moving that term, isn't it? In that case, we'd subtract the 2x, of course. Now, here's a little bit of a technicality, I guess, but they usually also want the x term to be positive. So how could I make this x term be positive? There's a couple ways. Yeah, divide everything by negative 1. If I divide everything here to make the, if I want the x term positive, if I divide through everything by negative 1, both sides, that'll take care of it, won't it? Or multiply both sides by negative 1. Well, that make it 2x, negative divided by negative, be positive 2x, and then a positive divided be a minus y equals positive 7. Okay, so technically, yeah, the x term they want to be a positive. So if you wind up with a negative x term, just divide everything by negative 1 and you're all done. The other thing is this. If I wind up with something like y equals say negative 3/4 x plus 5/2. And I want to change that to standard form. Well, the other thing on standard form is, what about fractions? No fractions, okay? In standard form, there are no fractions. So if I change this to standard form, how can I do that? Well, multiplying by the LCD again, which in this case would be 4. So I'm going to just go through here and multiply everything by 4. Because I've got 4 and I got 2, so the LCD of those would be 4. Multiply everything by 4. At some point, I guess you can do that in the next step, but multiply everything by 4. This, of course, is 4y. 4 is canceled there, so that's negative 3x. And then here the 2 goes into the 4 and leaves me 10. So now I have no fractions. Now just bring the x term, add it to both sides. Okay? All right, so if we want to change standard form, just usually a pretty quick little step there. Okay?